Okay, everybody, we're going to make one last attempt here to get everyone at least close to the same page of realizing how easy it's supposed to be to add non-concurrent vectors. And so what I've done right here is I put on this plane a bunch of non-concurrent vectors, and of course we could just draft a bunch of radial vectors, 1, 2, 3, 4, and we could do a sum of an r cross f divided by the sum of the forces which you add tip to tail, and that's going to get us a radial vector, which is that's going to be the moment arm vector. It gives us the moment arm, and that of course is going to be perpendicular to the line of force. We could do all that, or we could just learn to basically go through a process where you start daisy chaining. So what I'm going to do here is I'm going to grab this vector and this vector, and I'm going to go ahead and, without using any kind of great graphical aids, I'm going to grab that and I'm going to slide it, if I would. You see I'm sliding it along its line of force there. And I'm going to take this one and slide it there, so it looks something like that. And now essentially I've got two vectors, right? That when you add them together, you're going to have to remember that that is your line of, your point of application, or your line of, for your line of force. So if we add these two vectors together, we end up with what in the end becomes a resultant that goes from here to there. So that's a resultant. Once I have that resultant, I can grab, of course, this one and Control Z, hopefully. Don't want to do that. Try that again. I'm going to take this one here. I'm going to more or less, I'm going to add the two vectors together. I do that. I have a, what in the fact is a resultant. My resultant goes from there to there. That's a resultant of those two vectors. So these two vectors are no longer here. This is the point of application of the sum of those two. But now you're going to see that you can go ahead and hopefully slide this one down along its line of action, realizing that that is now your new point of application, and you can add this vector and this vector and get a new resultant with a new line of application and a new point of application, if you would. And I'll go ahead and try to use the highlighter for that one, see if that takes. So this is my second resultant, right? And so I'll put that for 3. So this is the resultant of 3 vectors, and now you're going to see that you've got one hanging out here, and you've got to look for its line of application. So I'm going to try to take this, see this one going up that way, and this one running up that way. Well, now what I'm going to have to do is I'm going to have to go ahead and take that one and slide it up to its point of application. And now take this one and slide it there, of course, but then once you're there, you slide it, you get it right there. That is your final place that you need to do a resultant, and your resultant then turns out to be of all 3 forces is this, which is going to be a force anywhere along this line of action. So that's pretty easily done in CAD. So what do you do to add in CAD and do that? You more or less daisy chain your additions by combining 2 forces at a time. 2 forces at a time, and the point of application of the resultant is at the point of concurrency, is at the point of concurrency. Give that a try. Mathematic, you'll see in the end, it's going to be sometimes a lot easier just to do the sum of the r cross f divided by the sum of the f's. That gets you the magnitude of the radial vector. And you know the direction of the radial vector, I'm sorry, that is not the radial vector, that is the moment arm vector. gives you the direction, and you know that that is perpendicular to the line of force of the resultant. However, this should work. You should be able to do this quickly, consistently, and well just using a scale and some triangles. And it keeps you from having to break vectors up, which is also another good, easy, reasonable way to do it. But you should be able to do this consistently a number of different ways until you own it.